Next we'll add some power to the actual chip. So pin 7 is VCC, so 1, 2, 3, 4, 5, 6, 7, that's VCC. So I'll wire that to the VCC rail, the +5 rail, and ground is pin 8. So that's this one here, and of course that goes to ground, to the ground rail. Right, and there's what I've just done in close-up, sorry. Right, next we need to provide a way to actually flash this. So we need an RX and a TX wire, or wires. I usually use yellow for this, but I'm going to use green this time. Right, the RX and TX pins are, RX is 2, so 1, 2, that's RX, and TX is pin 3, so there's TX, RX and TX. Okay, so RX needs to go to TX of the FTDI. So TXL, there's TXD there. So TXD. TXD, that is this one. This end one. And the TX of course goes to RXD, which is this one. Right. Okay, so that's the whole thing wired up. I'll zoom in on this so you can see what's going on. Hopefully that was quite clear. Well, we'll see anyway. Right, so now I've just created a new sketch. I've gone to Tools and then Board and then chosen Arduino Genuino Uno, and I've chosen my port, which is of course the port that it's plugged into. Then Programmer, I've chosen AVR ISP Mark II. So let's see what happens now. Okay, I've just thought that really it would be a good idea if I could test it in a bit of a better way than serial. So I'm just going to get an LED and wire an LED from pin 8 to ground. So I'll just show you that now. First I'll just put a resistor in just to make sure. This is about, I don't know the codes very well, but it's a low value one, I know that. I think it's probably about 150 ohms or 100 ohms, something like that. So I put a resistor in, and now I'll just wire this thing in. Okay, so that tells me that my sketch has worked properly. So I'll just show you what I've done in the sketch, or I'll tell you what I've done in the sketch anyway. I've gone to File, and then I've gone to Examples, then I've chosen Basics, and then go to Blink, and then when I've gone to Blink, I've overwritten the number that was in the pin mode and changed that to 8, and then where it says digital write and then the pin number again, I've changed that to 8, and then there's a delay, digital write pin number again, I've changed that to 8, so basically changed all the pin numbers to 8 because obviously that's pin number 8 there. Then the sketch says, well, it prints high and then it prints low, high, low, and it keeps blinking like that. Now it just turns out that this is actually a blinking LED anyway, so yeah, but that doesn't really matter. So it's working, so I'll tell you what you've got to do now. If you go to Arduino, press Control, well, I was going to say Control and U, but Upload, it's the same. So if you go to Upload, and watch the green bar on the bottom right, and as soon as the bar on the bottom right gets towards the end, Right, I'll tell you when. The bar is to the end now. Let go. Okay, I wasn't quite fast enough there, I'll try it again. But there's the reset button anyway. Let go now. And it says uploading, done uploading, so it's worked. So I think I'll show you again, but on the laptop. I don't usually put the camera up to the laptop because it's not very good, but screen capture is better, but okay, I'll show you anyway. So upload, then you can see here that it says progress, ready, now, and it says done uploading, and that's how to do it. So there we go, and that's how to make your very own Arduino, and it's fully working, and yeah, there we go. So I suppose it's a copy of the Arduino Uno, really. I'll just get the Arduino Uno and I'll show you so you can compare. Yeah, there's the Uno. Oh, it is a completely different chip actually. 328P-PU. But anyway, that's kind of what we tried to copy anyway. So there's our copied version. We've just got a chip, a clock, the FTDI UART, a capacitor, two capacitors there over the clock to stabilise it, obviously a resistor for the LED because otherwise it would potentially draw too much. We've got a resistor going from 5V to reset. Basically it resists any current that comes from 5 volts to the pin, because you wouldn't want a dead short from 5 volts straight to that pin. But the reason it's connected to 5 volts is because we want it to be logic high. We always want reset to be high unless it's actually being reset, in which case we want it to be low. So we've got the resistor there to keep it high, but to also resist an amount of current so that it doesn't draw too much current from the FTDI. And then we've got this wired up with it too, and this makes a dead short straight to ground, therefore pulls reset to ground directly for a split second. So basically, because this is a direct short to ground and this isn't a direct short because there's resistance on the line, when we press reset, power flows straight to ground, because of course there's more resistance in this path, so the easiest path is to go to ground, but of course that makes the pin low and therefore resets it. So it's a nice way of keeping the thing more stable, because you know that you've either got high or low, there's nowhere in the middle. Anyway, so probably going off topic a little bit there, but there's the Arduino anyway. So you've got your very own Arduino made for, well, I don't know, about £2 or £3, something like that. Anyway, I hope you enjoyed the video, and thank you for watching. Bye!